So this is Perl against 2048. This is me. Last talk I forgot to present myself, so I'm Mark. This is a talk about the talk I gave at Granada Perl workshop last year. Some of you already seen this, so no spoilers, please. This is available on GitHub. I wanted to do a different talk for the workshop, so I wanted to write code to play and win, if possible, at this game. And usually, one of my problems is I don't give talks about topics I master. So it's kind of a talk-driven learning. So I submit a talk, and then I learn about something, and then I give the talk. As you can suspect, it's not usually the best way to do it. So this particular time, I started to code 4 days before the workshop. So yeah, and I have no idea how to do it. So this is the game, 248, everyone knows about it. It's a prerequisite to understand the talk, so if not, I'm sorry. Yeah, I had no much time to code, so needed a prototype really fast to, yeah, maybe if I had to do 2 iterations, I'm really late. I dive into Stack Overflow, seeing what people is actually doing to solve this problem. I found a solution based on Minimax, which I didn't know it was supposed to solve this kind of problems, but it's an algorithm that was familiar to me, so why not? Minimax is a decision algorithm for games. It's usually used on 2-player games. Basically, it's trying to minimize loss. So it's not trying to get your best move, but to avoid the worst one. It models a tree with all the possible plays, and you need a function to evaluate how good is a specific board and aim to compare 2 plays. So it's better this position or that one. This is what more or less a Minimax algorithm looks like. It gets your best score and assumes that the player against you is going to select the worst for you. On the original talk, I had a lot of slides talking about this, but right now you have to look into Google it if you want to know more. Yeah, how can we use this to play 2048? Well, you need a tree with all the possible moves on a specific board. So the new tile that is going to enter is random, so you just generate all the possible moves and assume that the tile is going to be put on the place that is going to annoy you most. This is a really huge tree, and it grows really fast. So you have to put some limit on the evaluation you want to do. You want to look like 3 moves before, or yeah, and you need an evaluation function to evaluate the boards. So CPAM for the win. There was a game logic already developed, but was only playable by keyboard. I contacted the author, and in 20 hours they provide me an interface to program bots. So cool. There is a Minimax algorithm, so all the hard stuff is already done. The code is available on GitHub. Basically what I did was implement 3 functions. The 2 ones are the first 2 ones are mostly trivial, and the 3rd one I stolen it from the Stack Overflow, just translated from another languages. So yeah, did it work? What do you think? Yes. Yes.
So you finally Finally, you win it.
Yeah, I won it, and actually it plays like me, so I can actually just program while this algorithm plays. So yeah, that's it. Thank you.
Okay. I just wrote this lightning talk, so there might be errors, but I will try to do my best. And this lightning talk, I got the idea from one talk I was before here about BioPerl. Tony is here. Yeah, he is Tony. I saw one slide. He was using HTTP Tiny to do some request, and I saw the slide and it was like 4 lines, and I say he loves one-liners. That is really easy to do with one line. So this is about. Okay, if I never plug this, it won't work. So don't care. This talk is about a Mojo subcommand. The Mojo has a command to create application, but has a really nice feature that is mainly did for test Mojo applications, but you can use for scraping, for one-line scraping. And well, as you can imagine, I love Mojo, so I will talk about it. Mojo get is what you can imagine. It's just to get like any other command to do these things, but has some niceties. This will do what you expect. It will get all the page and give you back, but this is really hard to read. So you can say, give me the title, and it will give you the title tag. But I don't want the tag, I want the title. So I can say, give me the title, the text of the title, and you will get the text of the title. You can also say, give me all the A elements, and you will get all the A elements, like a lot of A elements in our homepage. But you can say, I want the 3rd element, and only the text of the 3rd element, and I can get that. But I also want the URL. So I say, okay, but from the 3rd A element, give me the attribute that's called href, and it will work. That's great. You can also say, this is from Tony's talk. You can probably want to know how a human is real name. I don't know if that's the topic. So you can say, I want JSON. So you can add headers here, and you will get all the JSON back. But I only want the scientific name. So what I will do is I will say, give me only the scientific name. This is a JSON pointer notation. So I will get Homo sapiens. But I can also go further into the structure, and I can ask for the parent scientific name. Of course, it will work. Or you can go into arrays, because there is a lot of children. So I can give me the first children name. It will work. And if you really like one-liners like Tony, you should see a Osho module that is part of the Mojolicious distribution. It's mainly made for one-liners, and you can use like this: Perl minus Mojo, M for the module, Osho for the name. Capital E is to use point-end functionality of Perl. And then you can say, get that mojo.us website from the DOM, get me the title and get me the text. And this is what I was using on the command. So the command is just like a easy way to use all the power behind Mojo user agent. And that's it. Thank you.
Okay, hi. Looks like the talk has to be in English. My English sucks, as you will see in a few minutes. So, anyway. The first line in talk is about aspects. Uriol has said in his talk that he loves methods and method modifiers and moves and everything, but these method modifiers look to me like a poor man's aspects. So I'm going to show you how real aspects look like. And just a minute, please. Okay, so we have two programs in Java. Sorry. One that computes the Fibonacci's numbers. It's a non-efficient version. You know, the recursive one that follows the mathematical definition, but is extremely inefficient. Okay? And then we have a JUnit code just for testing. The only thing that this code does is to make sure that the Fibonacci of 0 is 0, the Fibonacci of 1 is 1, the Fibonacci of 2 is 1, the Fibonacci of 3 is 2, and the Fibonacci of 8 is 21. Okay? It's just one test. So, I compile these two programs, but please pay attention, and I'm not using the Java compiler. I'm using the AspectJ compiler. But it doesn't matter because Java is a subset of AspectJ. So any correct Java program is a correct AspectJ program. I compile, I execute, and it's okay, the test. Well, but then I think, this is boring. I would like to trace the execution of this function. So I add an aspect. I'm going to change the execution of the code, but I'm not going to change a single line, a single character of the two files that you have seen. Okay? Now, the first one is a tracing aspect. Wait a minute, please. Fit tracing, okay. And what this code is doing. First, I define what I call a point cat. That's a set of interesting points in the execution of a program. Okay, the interesting points are any execution of the function fib. Well, fib, whatever, because there's a star there, okay? And I also want the arguments of that function, so I can get them. Before that point cat, I will write calling, and then I will get the name of the function that I am calling. I use a variable to indent the messages that I'm showing, and we have an after the call. We will write the result of the call and the kind of signature of the function. You will see. Okay, and then I have a private method that simply prints what I want. Okay, so I got the calls to fib, to Fibonacci, to fib whatever, and I intercept them. I put code there. And I execute the thing. I simply have, I must compile everything together. Nope. This one. This, I'm compiling the two files, Fibonacci and Fibonacci test, and then the aspect. Okay? And what happens when I execute? Please pay attention that I am executing exactly the same thing I execute a few moments ago. Okay, so now I have the trace of the code. But I didn't touch a single line of the original code. I simply added something called an aspect. But the problem is that, okay, this Fibonacci is like, you see, there are no separating lines between the traces. So I will add simply an aspect that what does is it adds a separation line between the traces. The thing is that the Fibonacci is recursive, so it's not that it's not as simple as saying, okay, when you found Fibonacci, write the message and then write a blank line. I have to forbid that this works inside the flow of Fibonacci. Okay, well, maybe it's a little complicated. Let me show you. Again, the same process, compile everything together, and then execute, and I have these blank lines separating the traces. You see? These blank lines are the ones I put. But now I want to do profiling. I want to know how much time every call spends in the call. Okay, so I have, of course, another. No. Okay. So now I say, in the original call to fib, not in the recursive calls, I want to measure the time that it takes between the original call and the final, and the result it returns. Okay, and since the result will not be nice to our eyes, I will add an aspect that simply defines a precedence between the aspects. And again, I compile everything together. And I execute the same thing, and now I have not only the trace but also the time it takes for every function call. You see, after the trace, there's the time it took to execute that call. But okay, I see. Fibonacci is a very inefficient function. It will be why? Because it calls repeated times to the same function with the same arguments. Okay, so let me get a kind of cache of my code, but not in the code, in another aspect. So no. No passa res, després també és meva, o sigui que... Ei, que si no, no podeu flipar. So I'm going to do some kind of memoizing. Well, let me show you. I compile, but let me show you what I'm doing here. I am just keeping track of the different results. Now my aspect has a hash table that relates the arguments with the results. So it does not compute more than once every call to fib. And when I execute, it doesn't compute again fib of 3, fib of 2, fib of 1, fib of 0. It only computes what it needs to be computed. And all of this has been done without touching one line of the original code. So using aspects, I, for instance, can turn an inefficient function into an efficient one. Okay? So, so much for aspects. This is what I want to show. And now, for something completely different. Okay. Yeah. What? Okay. This nothingness is Smalltalk. Okay? Smalltalk. Smalltalk is a language from the 70s. It's a language that has always been a graphic language. Smalltalk has never been programmed with BI or Emacs or nothing. It has an environment. Okay? An environment when you program in the system browser, you can try to find one class, well, whatever, and then you got the code of any method, just right here. But it's a kind of reflective language that I want to show some funny things. For instance, we have, this is Faro. This is a version of Smalltalk called Faro. We have a finder. Finder is interesting because I have the class object. Well, every class that has object in the name. And I can choose object, and then I have a browser in my object class. But, okay, this is not amazing. But we have another things more interesting. For instance, what was that method that when you pass 5, it returns 120? Oh yeah, factorial. The factorial. That, by the way, of course, Smalltalk has infinite precision, and you can compute easily, you know, like 1000 factorial. And there we go. This is 1000 factorial. Okay? But it's very interesting because it has, by default, I mean, it's a language very rich, and you can have, you know, an ordered collection with 1, with 2, and then you see, I want to inspect this object that was just created, and I can. Of course, everything is an object in Smalltalk, even the number 1. So I want to inspect the number 1, that's from class small integer, and I have the versions in octal, binary, character, and these inspectors are really useful. How? Well, let's see. This image of Faro has a recent final degree project of a student of mine that we implemented a BitTorrent client. Okay? And I only need to start a torrent. I just downloaded some torrent for a TV series, Mr. Robot. Okay, second chapter. Anyway, when I execute this thing.
Stop watching the series. Scrap.
Nah. When I start this thing, that I can do just by doing do it, the last thing I said is torrent inspect. Okay, so I have an inspector on an object that's alive. The thing is, why do I need a graphical user interface when I have an inspector? For instance, I'm downloading. No, sorry, I don't have internet. Okay. But anyway, I can interact with the object saying self stop, and the object stops, and then I can put it again. Oh my god, the demo effect. Okay, I don't have internet yet. Fuck. Why? No. I'm using it ROM. It's not the. But all day it worked perfectly. Not now, of course.
Try again.
Have to try to put it on and off again.
Of course, this is failing. Is failing, so I have to stop. I have to stop the object. No, fuck me. Okay. Sorry. No. No, I'm going to do this demo. Whatever it takes. So now I have internet. So
1 minute.
Well. So am I downloading? No. Because probably I'm looking for peers.
Can you see it here?
I only found one remote peer. Now I two. Okay, the object is alive, so the object is executing, and I can see the state of this object as it executes. So now I have 3 peers. Maybe I'm starting to download. Yeah, I am downloading, and I can prove you because now I have here a file. Well, a directory called Mr. Robot, whatever. And now I have a file that's growing. I started this, so it's downloading. I have remote peers, and this is what I wanted to show you. It's a live environment to work. You can inspect every object in the system at any moment. Okay, you see this is changing remote peers, and that's all I think. Sorry.
I am going to talk about the zip and pull request challenges. That if you don't know, is every people that you can act just have to send a mail to Neil Bauer, and he gives you every month a Git repository that is the source of a CPAN module. And I like to talk about it because most of the Git repositories are not CPAN distribution ready. Some have used the Zilla, or one that I discovered the last month that is called Minilla, that is the son of Godzilla. Well, the adopted son. And it's a source to know things about the band that you usually don't know because you don't need to use those modules. And you have to look minimally at the code to get something that you can change in the course of 1 month. So you get a vision more rich, because there are some tools that you didn't know, and looking at the model to know how they make the distribution, you know the tools, and there are beautiful surprises in the models. I like a lot of Minilla that they leave the Git repository ready to be installed via cpan- with the Git URL. So it's really funny, and you know a lot of things, and it doesn't cost a lot of time. You only have to get one pull request, and it didn't need to be accepted or no. You usually try to be accepted, but there are some models like the author is not purchasing the model, or is wishing to deprecate it, but don't have time, but because they don't wish to dedicate time to the model. So I wish you that try to participate in the spam pull request. Thank you.
Hello. Someone told me lightning talks was kind of like a group therapy, so I'll try to I don't know, cure myself in these 2 minutes, 3 maybe. So I hate JSON. I really hate it with the passion. Yay, why?
James Path?
Yeah, I kind of like James Path, yeah. But yeah, why? Because of this. This is JSON, and this is JSON too, and I hate reading it, and I hate parsing it. The thing is that we already have parsers for JSON, and that takes out some part of my frustration. So you have some type of module that converts JSON into data structures, hrefs and arrays, and yeah, but then when you have to use them, you want to cut your veins, because you have to treat things like that data structure this way. So and the thing is that what happens if this didn't have a key with users? Well, your program just blows up. So really the thing here is that we have a document that treats that is conveying some type of structure, right? So you have a user list, so we could call the first object a user list, and inside we have objects that are users. So welcome to my sort of therapy. It's just a module on GitHub trying to end some of this, some of my pains. So the thing is that you just declare a package user list, and you tell it to use Minimax data model, and tell it that it has an array called users, and those things are users. And you declare another object that is a user, and sorry, that is lacking the use Minimax data model, because I did this 2 minutes ago. And you tell it has a key that has a name, and then you just use, when you parse something, if it's invalid, it blows up, as you would expect, when you parse it. So you get, at the other end, you get a valid object model for that, for the JSON or the data structure you're putting into it. And of course, you can implement methods in those classes and call them after parsing. So for that user list, we could send the mail to everyone. And of course, you can tell, for example, that name is required. So if any object didn't have a name, the thing would blow up too. So thinking a bit, what I don't hate JSON that much, I just hate data structures or working with data structures that try to convey an object model. And yeah, I hate JSON too, because if you took a look for those with a clinical eye, that first slide was not valid JSON, because we only have one thing here that's a comma that makes it invalid. So go to GitHub. This is not on CPAN yet, because it's changing underneath, but if you want to, if you have the same pains and you like this type of access to JSON documents or any type of data structure, just go to GitHub and try it out. Thanks. Oh yeah, and the cat.